Hello viewers, welcome to my channel Connect Civilians. So in this lecture we are going to design a simply supported singly reinforced beam as per IS code 456-2000 where the maximum span length is up to 10 meter. Okay, so we are going to use this Excel sheet for the design of singly reinforced simply supported beam. Here is the initial value data that you have to fill by yourself, and here in sheet 2 your beam and your cross sectional views is given. Okay, so this will be your steel sections and this will be your beam section. Okay, now you have to provide the thickness of the support. Okay, so this will be column 1 and column 2, this will be a support. So there will be a column or a brickwork. Okay, so to provide the thickness of that bearings. Okay, so this will be the first one is for column 1. So our width is 300. Similarly for column 2 width is the same, 300, C1 and C2. Okay, in your case maybe the width of the both the supports is different, so you have to go with your data. And the clear span between both the columns is 4 meter. Okay, here it is 4 meter we have provided. Live load is I'm going to take as 25, but if you want to calculate the live load on the beam that is coming, so this here is your live load calculation sheet, and here you have to provide the height of the floor above. So the what will be height of the floor that is coming, you have to provide that for the calculation of the brickwork on the beam. Okay, so next, floor beam depth. If you want to deduct the above beam depth from the height of the floor, you can go with it, or you just provide 0. Okay, this will be much more safer value, but for accurate value if you want to go, so you have to provide the depth of the above beam that is coming on the above floors. Okay, so this will deduct uh, the height of the floor from the next beam depth. Okay, now density of the brick, you have to provide the density of the brick and the plaster, so it is 10 and 22. Thickness of the block work, so what will be the thickness of the block that we are going to take on the beam, so you have to provide the thickness. Here it is 150, and the thickness of the plaster is 12 mm. So you have to consider the thickness of the plaster on both the faces, that is outside and inside of the wall. Okay, so I will go with 12 for inner and 24 for outer. Okay, so our UDL acting on the beam will come as 7.514. Okay, so this will be your live load that is coming on the beam, so you can go with this value also, 7.514. Okay, so here you have to provide that. Okay, so here we are going to take a 7.514. So manually you can insert in this. Okay, so this will be your dead load, actually that the load that is coming, so this is a permanent load that is come under the dead load. Okay, so that will be okay. Live and dead load on beam, this will be same, and your FCK will be your grade that you are going to take for the concrete. So here we are going to take a M20, so here you have to insert that. So this will be a concrete grade, I am going with M20, so 20 you have to insert, and FI is your grade of steel. So what grade of steel we have to provide for the main bars? What will be the main bar? This brown bar, this will be your main bars, and this blue bar is your stirrups, this will be your secondary bars or shear bars. Okay, so that grade you have to provide. So generally for main bar we will go up to 500, and for shear uh, shear bars you can go up to 415 also. Okay, and or you can go what steel is available in market. Okay, So generally 415 is used for the stirrup, and if main bar we can use up to 500. So this will be your tensile strength of the steel. Okay, and dia of bar you have to give dia of bar for main reinforcement. So here you have to consider 12. So minimum dia of bar that we have taken for the main reinforcement is 12. So I am going with 12 mm, and minimum dia of bar that is will taken for shear reinforcement, that is for stirrups, is blue bar. So you can go up to 8 mm. Okay. So if design will not pass, we can increase the dia of the bar after that. First we will see whether it is going to pass or not. And factor of safety, you have to go. So generally we go with 1.5 factor of safety. Width of the beam will be, so here we have to assume the width of the beam that we are designing by ourselves. So here we are going the width of the beam by 300. Okay, go with 300, don't go with 350. Okay, so this will be your width of the beam. Okay, 300 it is. So you have to assume the width of the beam by yourself here. So minimum 300 we can go. Okay, or you can go up to 225 also, that is 9 inch. Okay, if it is not pass, then we can increase after that also. So now it will be okay. Beam type is your simply supported beam. Here you have to just select simply supported, don't select continuous. This will only design the simply supported beam. This actually will only design the simply supported beam. So here in black all the values will be calculated. You have inserted all the initial values. So your span to effective depth ratio is coming as 20. Effective depth calculator is coming as 200 mm. So we are going to take the effective depth according to this. So minimum effective depth that is coming right now is 200. So go with 200, or for safety you can go with more than 200. So this will be effective depth, or you can go with 250. This will be okay, and the effective cover will be taken as 30 or 25. You can go 25 also. So our total depth is coming as 275. Okay, if you want to decrease it, just decrease it also. This value, the effective depth, I am going with 225 right now. What will be your effective depth? So this, from top to this mid of the bar. Okay, so this will be your effective depth. So I am going with 225. Effective depth is 225. So total depth of the beam is coming as 250. So this will be your initial values. Self weight of the beam is calculated as 1.406, and total load is coming as 8.92. This will add your live load and your self weight. Okay, so it is coming 8.92, and ultimate load, so it is coming as 13.38, and it is multiplied by factor of safety. Now here design calculation will be shown. So this will be your design effective span, and this will be your bending moment, that is coming as 29.86. Okay, now your stress in steel will be, so it is according to 453, it is always uh, 2 into 10 to the power 5. So for if you are using another code, this value may vary, so that's why I have given an option to, if you want to change the stress in steel, you can change. Okay, for ISCO 456 2000 it is okay, and your limiting depth will be calculated 0.456 into effective depth, and your moment of resistance for balance section is coming as 0.133. So now this value, all value will be calculated. So our D effective depth calculated is coming as 224, and what we have provided, we have provided the effective depth as 225. Here we have provided 225, so the provided depth is more than the calculated, so this will be safe, but the value is slightly differs. Okay, so if you will see, either it is passing or not for in the reinforcement calculation. Here it is safe, so you can go with. So here it is coming under info section. Okay, so if it is under the info section, we can go for the design of singly reinforced beam. Okay, and what is singly reinforced beam? In singly reinforced beam, you have to just provide the design according to the lower bar, that is bar in tension. Okay, and this two bar is only provided for the support of your stirrup. Okay, this is not designed, this is just provided for the support of the stirrup. So minimum two bar you have to provide. Okay, and in singly reinforced, only the lower, that is in tension zone, it is designed. So it is under reinforced section, so you can go with singly reinforced beam. If it is not, it is balanced or over reinforced section, what you have to do, if you are want to design a singly reinforced, you have to again increase the depth. Okay, here, and if you want to, if you want to design a over reinforced section, you have to design with doubly reinforced beam. So so we will talk in another lecture about doubly reinforced beam. Here we are going to design the singly reinforced. Okay, so right now it is under reinforced section, so this will be okay. We are going to design according to singly reinforced beam. Okay, now your main reinforcement will be calculated here. Area of steel will be calculated. The minimum tension zone beam area steel is calculated. Maximum will be calculated. Area of bar will be provided as coming as, the number of bar required is 3. Here minimum you have to provide 3. Okay, so this will be safe. So you have to check it, both the red boxes are showing you safe. Okay, if it will show you not safe, you have to increase the number of bar. Okay, in both the boxes. So here number of bar provided you have to increase if it will show you not safe, but here it is okay. So if you decrease here, okay, so here it is showing you not safe, set the number of bar again. So what is happening, area of bar provided is coming as 339, but area still required is, we have calculated as 374. So increase the bar here 4. Okay, so now it is coming as 452, so this will be okay. Here it is showing you safe in both the boxes, that will be okay for design. Now you can see here, that is our reinforcement for main bar is coming as 4 number of bars of 12 mm tire. Okay, so this will be okay for main bar. And for shear reinforcement design, here it is come, it will also show you in the diagram. Okay, for main bar it is 4 number of bar of 12 mm dia, and for shear, now here it is calculated for shear reinforcement. So factored shear force will be calculated 28.27, nominal shear force will be 0.56%, of tension reinforcement is 0.893, and your shear reinforcement value is be coming as, so here it is showing you shear reinforcement not required. Okay, but you have to provide the minimum shear reinforcement here also. Okay, so from IS code 456 2000 on table number 19, from table 19 you have to find the design shear strength. Okay, so here by percentage of steel and the grade of the concrete that we have used, you will get the value from IS code 456 2000 on page number 73 here on table number 19. So we are using M25 M20 grade of concrete, and here our percentage of tension reinforcement is coming as 0.93. So for 0.893 it is coming between 0.75 and 1. Okay, so 0.75 and 1, and you for grade of concrete M20 you have to fill the value for the same 0.75 and 1. M20 will be 0.56 and 0.62. Okay, 0.56 and 0.62. So our design shear strength will be coming 0.59. So here value will be taken as 0.59. So you can use this interpolation table for the calculation of your design shear strength value. Okay, so here design shear strength is greater than our nominal shear strength, so here it is saying not required, but you have to provide the minimum shear value for this. Okay, so we are going to consider the 8 mm of dia for the stirrup of two leg. So what is two leg? This two, you have to provide two leg minimum. Okay, well, leg 1 and leg 2. Okay, this leg 1 and this leg 2. So area bar will be coming as, area of bar provided is coming as 100.5 mm square, and here value will be okay. So here if you want to change the value to 6, so this will be also okay, that was not a problem. Now this will be okay. So we have provided the stirrup of 6 mm of dia of two legged. So now spacing is coming as 169. So you have to provide this. In place of stirrup. Okay, here it is 6 mm dia of two leg at 116 mm center to center. Okay, so we have designed the reinforcement and the depth in the way, and here will be your deflection check. So your percentage tension reinforcement is coming at 0.893. So FX value will be calculated from IS code 456 only. So from graph I will show you the graph. Here will be your modification factor for tension reinforcement. So from this value you have to calculate. So Fs is coming as 240.14 Newton per mm square. So according to this we are going to find out the modification factor value. So our Fs is 240.14, so it will come around here, and our percentage of reinforcement is 0.893. So 0.893 will come near 0.9. Nearby here it will be going to come 0.9. So from this to this, here it is 240, it will come around here 0.8. So the value of modification will come at 1, 8, 0.91. So it will come around 1. Okay, so our L by D provided is coming at 18 point, and our L by D maximum will be 20. So this will be safe in deflection also. So if it is not safe, we have to again increase the depth or width or the reinforcement. Okay, So here we have done the designing of our beam, singly reinforced beam, and in figure 2 you will see the all the data how your stirrup is provided. 6 amount of bar stirrups of 2-legged at 116 mm spacing will be provided, and in this section is also shown you here. A minimum 2 bar will be provided to support the stirrup. So you have provided 2 of 10 mm of dia. Okay, you can go also with, if you want to, 2 bar of 12. Okay, so this bar is only used for the supporting of the stirrup. This will be your main bar that we have calculated 4 number of bar of 12 mm dia. So this will be your 4 numbers. This will only show you the figure. You have to provide the 4 number of bars, A1, 2, 3 and 4. Okay, so if you want to provide like this will be okay, or you can provide in 2 layers, 2 bar at the bottom and provide the spacer part between these, and 2 bar at the top. Okay, in tension area only. And this will be your section, and here it is provided from C1 to C2, and this orange bar is your main bar, this one is your stirrup. So here we have done the designing of the singly reinforced beam simply supported, where the span length is up to 10 meter. So in next lecture we will see how to design the beam where the span length is more than 10 meter. Okay, so if you like this video, please subscribe to my channel. Thank you.